Hello everyone, student. Okay, today I will continue my lesson. My lesson is chapter 5. Today I go through the chapter 5 for half. So I want to repeat again for the chapter 5. There's a fundamental of the wave. Okay, let's see this one topic. They're talking about the wave. What we need to learn about the wave. We got water wave, sound wave, and also the light wave. So from here we're starting for introduction. Okay, wave can be produced by an oscillating or a vibrating system. So for example, the oscillating is let's see the diagram here. They got the iron bulb joined together with the spring. So that means when the bulb just vibrate, they will touching the surface of the water. When they're touching the surface of the water, they will produce a water wave. So you can see the diagram here. They got one of the water wave. Okay, when they're touching, they find it the water, they will stay there, but you can see the shape. The shape of the wave is a circular. They will go outside. Okay, after a while, when it just finished, that means you cannot see about the wave. So this one we call water wave. Okay, now we see the second one, the vibration of the tuning fork. Okay, tuning fork is a bottom, this one. This one is a tuning fork. So when they hit the tuning fork, they will produce the sound wave. Okay, this one, the sound wave they produce because they got a molecule to bring the sound pass through to each other. Finally, they go our eardrum. After that, we can listen. So this one is one of the wave need the medium to travel. There's a sound wave. Okay, second one, we see the oscillation. Oscillation is a pendulum to oscillate. Another one is a vibration. Okay, these two situations must be repeated motion. After that, about the equilibrium position in a closed path. So this one is another situation. Later we will explain what means of oscillation, what means of vibration. These two situations, they're doing the thing is a repeated process. Okay, now we go through our topic. What is wave? Okay, wave is produced by the source of vibration. Something is vibrate or something they are oscillate. So they produce a wave. Okay, as a wave travel a medium, through a medium, there's no transfer of matter, but only transfer the energy from the vibrating source. So I highlight already. This one is important. When the wave just travel, they never transfer the matter. Example, the water. They never bring the water go together. They just transfer the energy from starting point to ending point. So this one is what means of the wave. Okay, let's see an example for this one activity from your textbook. Okay, they want to generate the idea. They transfer energy without transfer the matter. They're using the slinky spring and also the ribbon. So you see the ribbon, the tight at the one of the part of the slinky spring. Okay, let two people, the student, they go to hold each other. Okay, now the end of the A, they are moving. End of the B, they are fixed. They never move. Okay, how the student they move at the end A, they shake the slinky spring up and down. Okay, when they shake to up and down, what you can observe? You find it the spring, they were moving, just like the wave to moving. Then where they go, they just move, go to the right hand side. Okay, what happened for the ribbon? Now we're going to see the diagram. Okay, this one is a ribbon, the type here. So from the motion, when the student A, they move up and down, the ribbon motion also up and down. But the direction of the wave pattern is that from the A, go to the right. This one we call energy transfer. Okay, so from here we see the explanation. Movement of the wave from the end A to the end B transfer energy from the A to B. So this one situation we call it the energy is transferred together with the wave. Okay, but the matter how? Now the matter is a ribbon. So the ribbon only just vibrate, okay, about the fixed position. The ribbon does not move together with the direction of the energy. So this one is one of the concept they want to bring for you, what means of the wave. Just transfer energy without transfer the matter. Okay, now we're going to see the type of the wave. Okay, wave can be classified by the two types, mechanical wave and also the electromagnetic wave. Okay, let me see what means of the mechanical wave. Okay, mechanical wave is a wave that need the medium to travel. Okay, example, we got water wave, sound wave, shock wave as an earthquake, and also the wave with the string and also the spring. Okay, another one is an electromagnetic wave. That's a do not need the medium. Do not need the medium means although in vacuum, they still can travel. So example here we got radio wave, light wave, infrared, and also ultraviolet. These all that mean no, don't have any A molecule. The electromagnetic waves that still can be traveled to each other. Okay, now we go and see the characteristic. Mechanical wave means require the medium to transfer energy from one point to another point. Okay, they make up with the vibrating particle of the medium. Okay, example, just now I show you the single spring vibration. So example for mechanical wave means water wave and also the sound wave. That means they need the medium to travel. Okay, for the water wave, how you can see the water wave? Because of water. After that, you can see the pattern. So that means they transfer using the liquid molecule. Okay, another one, the sound wave. What is the molecule? What is the medium to help the sound wave to travel? That's a molecule. So this one, they need the medium to travel. Now we're going to see electromagnetic wave. Electromagnetic wave means they no need the medium. After that, they can travel the energy. Okay, let's see. Makeup of the oscillating electric and also magnetic field. They're using the electric and also magnetic field, but make sure these two things, electric and magnetic field, perpendicular to each other. After that, they can travel. So from here, example for electromagnetic wave, we got radio wave and also the light wave. So you go to differentiate what's a mechanical wave, what is the electromagnetic wave. Okay, another one is a stationary wave. Okay, stationary wave is produced when the two identical progressive waves. That means two waves should be the same. They are on the way to process. Okay, they're moving in opposite direction. Okay, both opposite direction. After that, they collide to one another. Okay, example, let's see the diagram. Okay, this one is a diagram. The wave together is the same maximum height. Then after that, they move in opposite direction. Okay, so then after that, they will collide to each other. This one we call stationary wave. Okay, another explanation for stationary wave is the wave where the profile of the wave does not propagate with the time. So that means when they just produce the time, they will always keep at the same path. They never travel with the time. They will stationary there. This one we call stationary wave. Okay, now we go and see the two main type of the wave. Okay, the first one we call transverse wave. Okay, another one is a longitudinal wave. So this one is the two main of the type wave we need to know. Okay, let's see the transverse wave. The explanation. The direction of vibration of the particle. That means the particle how to vibrate. They must perpendicular direction of the wave propagate. So you see this one diagram. Okay, you see this diagram. So first one, can you see the red color? Red color is a vibration of the particle. The particle how to vibrate? They move up and down. Okay, can you see the direction? There's a up and down. Okay, the blue color. The blue color means the wave how to travel. The wave will travel from the left to the right. So from here, now we need to mention these two physical quantities in the transverse wave. First one, direction vibration particle, up and down. Okay, another one is a wave travel, go to the right hand side. So now we join together. Vibration particle perpendicular to the wave propagation. So we call it as a transverse wave. Okay, must two join together. Vibration of the particle perpendicular to the direction of the wave travel. So this one we call transverse wave. So example here, okay, when they move up and move down, this one we call vibration. So when they move up, this one situation we call it as a crest. Maximum height we call crest. Okay, at the bottom one, maximum the lower part we call trough. Okay, so this one is a two situation shape when they just vibrate. So direction go to the right is a wave. Wave is always go to the right because they transfer the energy. then the up and down should be the source of the wave, how you move it. That means how you shake the spring. So you shake the spring is up and down, then the wave is travel to the right. So these two is in perpendicular, so we call it this a transverse wave. So example for transverse wave, we got water wave and also the electromagnetic wave. Okay, now we go to second one. There's a longitudinal wave. Okay, longitudinal wave, we also talking two things. One is a particle, another one is a wave, how to travel. So from here they say the direction, vibration of the particle is parallel. So can you see the hand is moving the spring in parallel, left and right, left and right. So how the wave to propagate? The waves always propagate to the right hand side, energy transfer. So you find here, particle vibrate left, right. Then the wave travel always go to right. So from here we can call these two situation is parallel. So now you just convert the word to parallel. Just now is perpendicular, now is parallel. So from here when I just shake parallel, you can find closer part. You also can find further part. Okay, closer part we call it there's a compression region. They compress together. When there's a further, we call it rarefaction region. So because of these two situations, they bring the A molecule. A molecule is closer, far away, closer, far away. Finally, the sound wave can be traveled. Cool. So example here, longitudinal wave is a sound wave. This one is another example for the longitudinal wave. So you can see about the compression and also the rarefaction. Okay, this one is a closer compression. This one far away is a rarefaction. So this one direction how to propagate. Direction is always go to right. Okay, bottom one is one of the example how the sound wave can be traveled. Okay, the molecule to bring the sound wave to go to right hand side. So you can see the molecule, A molecule, the closer, that one is a compression. When the far away, that one is a rarefaction. So this one is a longitudinal. They move by the perpendicular to each other. Okay, let's see the characteristic of the wave. Okay, what changes can you be observed? The wave propagate across the water surface. So can you find it? From the deep, they go to the shallow part. Okay, now the water also travel. Okay, direction of the water wave to travel. Okay, what you can see the difference. First one, you can see the shape. Okay, the shape of the water wave, they become higher and higher. Okay, another one, you can find it. The crest and another crest become closer. This one crest, this one crest. This one also crest, this one also crest. You find it, they become closer. So from here, we need to know 5 physical quantities for the water wave lah. So example, water wave, sound wave, also like this. We need to know the 5 physical quantity to do the calculation for the wave, how to travel. First one is the amplitude. Okay, amplitude. Number 2 is a period. Period means the time taken. Okay, frequency. Frequency means 1 second you vibrate how many times, we call frequency. So example for your ticker tape. Remember the ticker tape, 50 Hertz. 50 Hertz means 1 second you vibrate 50 times. We call it that's a 50 Hertz. So that means I give you 1 second. After that you can move how many times, that one we call frequency. Okay, wavelength. Wavelength is the distance for the wave. Okay, from this part you go another part, the distance is how long. So we call wavelength. And last one is a wave speed. That means the wave travel how fast. That one we call wave speed. Now we go through one by one. Okay, let's see the first one, wavelength. So wavelength, the symbol is, okay, make sure you know how to write. This one we call lambda. Symbol for the wavelength, there's a lambda. Okay, now it's a definition. The distance between two consecutive points. Okay, I already highlight the word consecutive point. The meaning for consecutive point means berturut-turut. Means first one, okay, example x1. x1 is a crest, is it? So the consecutive crest is which one? x2. Agree or not? We cannot say x3, is it? x3 not consecutive. x3 just another crest. So from here, wavelength you want to count, you must find 2 consecutive points. Okay? After that, you must say in phase. In phase means you up, another one also up. Okay? X1 and Z1, is it in phase? Not in phase. Because one is a crest, another one is a trough. So where you want to start, example, you start with X1, you want to count about the wavelength, you must count another consecutive, also crest. Then we call this a lambda. So X1 to X2 is a lambda. X2 to X3 also is a lambda. X3 to X4 also is a lambda. So if I say X1 to X4 lambda, so your answer is wrong. Okay, we must find the consecutive. If you start from Y1, so where is your lambda? Your lambda must start from the Y2. Okay, you start from the original is 0, is it? So you must find the nearest also is 0. So if I say this part, is it correct or not? If I start Y1, so this part is a 1 lambda. So your answer is wrong. This one just half lambda. You must let the wave to complete crest, go to trough, then go back. Then we call that one is a 1 wavelength. Okay, this one is a longitudinal. We see how to find the wavelength. Okay, the wavelength, they say the distance between 2 successive. Okay, just now is consecutive. You also can using the word for successive compression or successive rarefaction. So for example, P1 is a compression. So the consecutive, or you say the successive compression, where is that? There's another compression. There's a P2. So from here, we can say that there's a lambda. So if I find for rarefaction, Q1. Q1 is a rarefaction. Then we find the consecutive rarefaction, there's a Q2. So this one we also can call it as a lambda. Okay, so this one is a wavelength. Okay, now we go and see another one that's called wavefront. Okay, wavefront means the line that joining all the points in the same phase are called wavefront. So can you see this part B? Part B is a crest. Part A also is a crest. So if I join all the points at the same phase, so this one we call the wavefront. So another example also here. Can you see all the crest is up? Then I join all the straight line at the crest. So we call this one is a wavefront. Okay, after that we got wave speed. Okay, we're still using the V. Okay, wave speed means the distance moved by the wave in 1 second. So I want to count 1 second, your speed of the wave, how far, the distance where they go. So we're using unit ms-1. The wave speed depends on the medium the wave are travel. So that means water and oil and also the mercury. This one is a 3 different of the medium. So we also need to depends what medium, then the wave also will be changes. Okay, so depends the medium like in the air and in the water, sure in the air faster. Okay, because the air molecule is far away. So from here we're going to see the equation. Wave equation for the wave speed, there's a V equal F lambda. So this one is the first equation in this topic. V equal F lambda. V stand for speed. F stand for frequency. Lambda stand for wavelength. Okay, all using SI unit. Okay, now we need to go another 3 of the physical quantities. We got amplitude. Okay, amplitude means what? The maximum displacement from its equilibrium position. Okay, let's see the first one, pendulum bob. Okay, center. The 0 is a equilibrium position. So when I pull maximum height, then I release until go to equilibrium position. This one we call amplitude. So from here they say maximum displacement from the equilibrium position. So that one we call amplitude. Okay, amplitude also related to the loudness in the sound and brightness in the light. If I say amplitude for the sound is very high, means your sound is very louder. So if I say, well, here the amplitude very high for the light, so means what? the light brightness should be the highest. So this one called amplitude. So for the vibration of the spring, we also can say which one is the amplitude. Center is a 0, equilibrium position. When I just pull until maximum part, this one we call amplitude. When you just pull from the equilibrium position to the maximum length, that one we call amplitude. Okay, period. Period means the time taken for one complete oscillation. So that means I let you to oscillate one time. So I need to know the time taken. That one we call period. Remember we do the experiment for pendulum. I call you to do the 20 times for oscillation. So why we need to do the 20 times? Because we need to find the period. Period means one complete oscillation, the time is how long. We cannot catch the time. Too short. Because you let the pendulum to one complete oscillation, the time is too short. So normally we do it by 20 times. After that we go to dy. After dy, that means we can find the period. So this one SI unit is a second. Okay, frequency is the number of complete oscillation per second. So means I give you 1 second. After that you go to do the oscillation. After 1 second, then you see how many times you go to oscillate. That one we call frequency. Same like the 50 Hz we learned from the ticker tag. They vibrate for 50 times in 1 second, so we call it there's 50 Hz. Okay, unit for the frequency, Hertz. Okay, relationship between the frequency and period, F equal 1 over T. Okay, you want to find the period, you must have the frequency. Okay, you want to find the frequency, you must have the period. Then we can find it. So this one is a 5 physical quantity we need to learn about the wave. Okay, now we're going to see the graph. Okay, this one, the graph is a displacement against the distance. Okay, means we never related with the time, just displacement and distance. Okay, let's see the graph. Okay, this one is a maximum height. Maximum height is it? So this one also maximum height from the bottom. So from here we can find about amplitude. Agree or not? Amplitude just halfway only, no need go up until the bottom down, just until the horizontal. So this one we call amplitude. So wavelength, how to find the wavelength? Starting point, if I start from here, where is my ending point? This one is another ending point. So this one we call one complete oscillation. So this one we call wavelength. Okay, let's say example, you say I don't want to start from here, I want to start from the middle. Okay, I want to start from here. Okay, if I want to start from here, where is the wavelength? So you must count up, then go back until here. So this one we call it as a lambda. This one is another lambda. So from this one graph, displacement against the distance, what we can find? First one, amplitude. The second one, we can find about the wavelength. Okay, now we go another graph. There's a displacement against the time. Okay, let me see what we can find from here. Okay, first one, the pattern is the same. Just now, here is a time. Just now, that one is a distance. Okay, from this one graph, also same. We can find amplitude. Okay, amplitude is a maximum displacement from the horizontal line. Okay, now, we never find wavelength already. Now we need to find is a period. So period, the pattern, how to find, exactly same like the wavelength. Okay, exactly same. Just you change about the physical quantities. Okay, if you start from here, okay, where is the end of the period? So this one we call one complete oscillation. So this one we call period. Okay, if I start from here, okay, I start from here. So where is my period? The period must be here. Okay, so this one we call one of the period. Okay, this one also called period. So the pattern you want to find the period and wavelength should be the same, but you need to see the x-axis is distance or time. Okay, if time, sure you find period. If distance, sure you find wavelength. Okay, after I find the period, I still can find one more thing. That is frequency. Okay, we can find frequency if you get periods. So from here, this one graph, that means we can settle 3 of the physical quantities. Okay, this one is an activity 5.6 from your textbook. So make sure you need to do the calculation. Okay, they show you two of the graph. Okay, I want you to find is a 5 physical quantity for every of the graph. Okay, sure, the first one you can find period. The second one you cannot find the period. So the first one cannot find the wavelength. Another one you can find the wavelength. So example. So I give the example first. Okay, so from here the first one diagram. So first one amplitude. Amplitude is how many? So we see the maximum height lah. Okay, the amplitude. Both sides also can be found. This one is a 3. This one also 3. Okay, period. So period for the first diagram, we can find the period. If I start from starting point, where is another ending point? Must be here. So this one we call period. So your period is 0.5 second. Okay, another diagram we cannot find it. Okay, after that you can find about the frequency. So the frequency is 1 over t. Then you give the answer. Okay, wavelength. Wavelength, you need to go another diagram to find what is the wavelength. After that, wave speed. Okay, wave speed, that means you can combine the two diagrams to find it. V equal F lambda. Okay, so this one answer I will give you for the next lesson. Next lesson sure discuss about the exercise. So please do these activities. Okay, next we're going to see the river tank. River tank is one of the instruments to find out what is a water wave. Okay, this one is a diagram for the river tank. Okay, this one is a side view. This one is a back view. You can see the diagram for the river tank. We put the water here. After when I just on the light, then okay, you can see here, this one is a result, the water wave from the river tank. So when I'm using the plane dipole means there's a straight line. So when they're just touching the surface of the water, they will start to vibrate, is it? Because you control the frequency. When you vibrate, you find it the line, straight line produced. So after you using the light to refract, you can find it there's a bright and also dark figures. So if I'm using the spherical means a circle. When I'm touching the surface of the water, when it start to vibrate, you can see the shape. The shape of the wave produced as a circular. Okay, so this one is a water wave produced by the river tank. So you can see this one diagram is one of the video. Okay, bright and dark, when I'm using the spherical. When I'm using one dip lah, they're touching to the surface of the water. Okay, you can repeat to see. So this one is a water wave. Okay, so from here, let's see the example, what you need to do. Okay, this one is an example from your exercise. Okay, let's see. A student, they move the end of the long spring with the side to side 4 times per second. 4 times per second means what? 1 second they move 4 times. So that means we know the frequency, there's a 4 hertz. Okay, the wavelength of the wave of the spring 0.6, lambda 0.6. What is the speed? So you can using V equal F lambda to find the answer. Okay, so you can check the answer here. 4 times 10 is 0.6. So the answer is 2.4 ms negative 1. Question number 2. Radio wave travel speed. Okay, they produce the speed for you. Okay, what is the wavelength? They want to find lambda of the FM radio wave received at 200. Can you see the word mega? Okay, make sure you know the mega is how many. Mega is 1 times 10 power of 6. Now they want to find what is the lambda. So V equal F lambda. So you take V over F. Okay, so V 3 times 10 power of 8. Okay, 200 times 10 power of 6. So this one is a frequency, megahertz. Then lambda. So we find the lambda, there's a 1.5 meter. Okay, let's see the example 3. Example 3, they show the diagram. One end of the rope is shaken. Now the graph, they show the one of the particle movement in the time. Now the rope, they vibrate at the frequency 8 Hertz. They told you the frequency. Now we go to check. Displacement versus distance. Means we can find wavelength. We cannot find the period, is it? But you still can find the period when they produce the frequency. Okay, depend the question. First one, we find the amplitude. So amplitude means a maximum level. Where's the maximum level? 0.5. Okay, follow here, meter. Okay, what is the wavelength? So wavelength starting point, go another starting point. So should be 0.8 meter. Okay, what is the speed? Speed is a V equal F lambda. So we just applied it. So this one is the answer. So amplitude is 0.5. The wavelength is 0.8. Then the wavelength, the wave speed is a 6.4 ms -1. Okay, now we go to the example 4. Example 4, they show about the tuning fork. There's a vibrating. Okay, based on the figure, this one is a sound wave. So what is the amplitude? Oh, can you see the vibrating of the tuning fork? Left to right is a 4 cm. Remember, the amplitude is a halfway only. So the center is a horizontal. So when you go to the right, actually you go 2 cm only. So that one is an amplitude. Okay, how about the wavelength? Okay, we need to see here. Okay, is it the wavelength 150? The answer is wrong. We need to count. So first part, we go and see. Okay, this one is a rarefaction. So we need to go another rarefaction. Can you see this one? From the rarefaction, go another consecutive rarefaction. So this one we call it as a lambda. 1 lambda. Now from the second rarefaction, I go another rarefaction. So this one is another lambda. So until third rarefaction, go to the third rarefaction. Okay, here. So this one is another lambda. So from here, I get it 150 cm. Inside got how many lambda? 3 lambda. So you want to find the wavelength, you must take 150 divided by 3. So divided by 3, you get 50. The answer is cm. In cm, unless they want you to change meter. Okay, last one. What is the frequency of the sound? If the speed of the sound wave is 330. So make sure you see the unit. Now it's a ms -1. Means the later the lambda, you need to convert become meter. Okay, I show you the answer. Amplitude 0.2 meter lah. If you write cm, 2 cm. Okay, wavelength is 150 divided by 3. That's a 50 cm. Okay, after that you want to find about the frequency. This one is a 330. Then the frequency we don't know. The lambda you must convert become the meter. So I find it the frequency is a 660 Hertz. Okay, so your homework should be the 5.1 activity from your textbook. Copy the question and give the answer. So I will discuss the answer for the next lesson. So our lesson just until here only. So thank you for your watching. If you don't understand, then you can PM me. Please complete your tutorial for the